We've talked about the definition of the derivative, and now we're going to actually use that definition to calculate some values. So we start with the function f of x equals x squared minus 2x. The definition of the derivative, which is what we always need to start with, is that f of x equals the derivative of f of x is equal to the limit as delta x approaches 0 of f of x plus delta x minus f of x divided by delta x. So now we know what f of x is, and we've got to go plug some things in. So this is also equal to the limit as delta x approaches 0. Make sure you're always writing this limit term until we actually eliminate it. And it's going to equal the function x plus delta x squared minus 2 times x plus delta x. And so that's this first part. You can see that all I did was I took everywhere that there was an x in f of x and I replaced it with x plus delta x. Then I'm going to subtract the function unmodified, x squared minus 2x. And then this all gets divided by delta x. So now we're going to come down here, write out our limit expression. And we need to start expanding this and simplifying. So on the top, we're going to get x squared plus 2x delta x plus delta x squared minus 2x minus 2 delta x minus x squared plus 2x. Pause the video here if you need to take a second to check and make sure I didn't make any mistakes. But now we can go on and we have limit as delta x approaches 0. We can look at anything that'll cancel. So this x squared will cancel with this x squared. The negative 2x and the positive 2x will cancel each other out. And we're left with the following: 2x delta x plus delta x squared minus 2 delta x divided by delta x. And now you'll notice all of these terms share a delta x, so we can factor out, divide delta x by delta x, get it equal to 1. So this is also equal to the limit as delta x approaches 0 of 2x plus delta x squared minus 2. So that shouldn't be squared, that should just be delta x. So 2x plus delta x minus 2. And then when we take the limit as delta x approaches 0, that is equal to 2x minus 2. So in other words, f prime of x is equal to 2x minus 2. And so this is how we use the first form, the general form of the derivative definition, to calculate the derivative function from a known function. In this second example, we want to find the derivative of square root of x. So similarly, set it up with limit as delta x approaches 0 of, I'm going to skip straight to plugging things in. We're going to have square root of x plus delta x. And if you want to write down the definition, that's probably good practice. But I'm just going to go straight to plugging things in here. So now we have a little bit of a tricky problem here because this doesn't immediately show how do we start simplifying. So you start to learn some tricks. Do I expect you to know that this is what you should do? Not really. But we can look at rationalizing this. Anytime you have square roots involved and pluses and minuses, it's a good idea to think maybe rationalizing could help. So I've basically put the, instead of a negative, we have a positive, so that then we know when we multiply this, this is the form of the difference of two squares, yada, yada, yada. You'll see how that simplifies if you're not quite sure. If I'm going too fast or you don't understand, flag me down in class and we'll talk about it. So this will give us the limit as delta x approaches 0 of x plus delta x, in other words, this first term squared, minus the second term squared, which is square root of x, all over delta x times the square root of x plus delta x plus square root of x multiplied by that delta x. Now we see nicely that the x and the negative x cancel. We get the limit as delta x approaches 0 of delta x divided by delta x times square root of x plus delta x plus square root of x. The delta x's can cancel, and we get the limit as delta x approaches 0 of 1 over square root of x plus delta x plus the square root of x. When we plug in 0 or when we find the limit, that's going to give us 1 over square root of x plus 1 over, or sorry, plus square root of x, and that ultimately means that f prime of x is equal to 1 over 2 square root x. I know I went through that pretty quickly. Go back through and double check it if you want to check, or just pause and look through the math. Ask me in class if you're unsure, but the point here is seeing again that we can just use that limit definition, do some clever math to simplify, and that gives us the derivative at the end. Finally, I want to show you using the alternate form, which again we can only use if we're trying to calculate the derivative at a specific point. But in this case, we will find the derivative of 1 over x at x equals 2. So we start with the derivative, so f prime at x equals 2 can also be written as f of x minus f of 2 over x minus 2. And these can be written in either order because all that matters is that we're finding the same direction. So if I switch them, they'd both be negative and the negatives would cancel out. So another way, I'll write this up here, f prime of a, the general form, is equal to the limit, which I'm missing here, limit as x approaches 2, limit as x approaches a of f of x minus f of a over x minus a. Now what we need to do is plug in our function. So this will be limit as x approaches 2 of 1 over x minus 1 over 2 over x minus 2. And this we can kind of just start doing some simplification. Again, it's all about just finding some clever math for how do you simplify this. And so in this case, I'm going to reverse them and I'm going to factor out a 2 on the bottom. The reasons why will become clear in a minute. So negative, and then I can write 1/2 minus 1 over x. And on the bottom, I'm going to factor out a 2x so that I can write this as 1/2 minus 1 over x. Yeah. So again, factoring out the 2x means I got 1/2 for this first term, 1 over x for the second term. Now you'll notice that I have these nice terms that match, so they cancel. And then we get limit as x approaches 2 of negative 1 over 2x, which should equal to negative 1 over 4. So in other words, f prime of 2 is equal to negative 1/4. And again, this is just knowing or finding the trick for the clever algebra. We don't expect you to have that super mastered, but I want you to be able to see this and understand what we're doing so that when it comes up, you'll know, oh, there's a clever math trick, and you can kind of seek that out or play with some things to find it.